In this video, I'm going to be going over the double angle and the half angle formulas. So we'll talk about the double angle formulas first. So suppose we have something like this, sine of 42 plus 42. Now, we could very easily use a sum or difference, or rather just the sum formula here to expand this out. Now, because 42 and 42, because those are the exact same angle, we could write this as sine of 2 times 42 here. So if we let theta equal 42, we could say that this is sine of 2 times theta. Now, sine of 2 times theta, well, that's the same thing as sine of theta plus theta. So what happens when we expand this out? Let's use the sum formula. And the sum formula here is going to be sine of the first times cosine of the second plus sine of the second cosine of the first. And everything is theta because the first angle and the second angle are the exact same. So when we simplify here, we're going to get 2 sine theta cosine theta. So this is the formula, what we say, or what we call the double angle formula for sine. We also have double angle formulas for cosine and for tangent, so let's go ahead and derive those. For cosine, I'm going to write this as a plus a. So this is just the sum formula when both angles are the exact same. How this works is we take cosine of the first, cosine of the second, we change the operator, this becomes sine of the first, sine of the second. So we could write this as cosine squared of a minus sine squared of a. So this is one form of the double angle for cosine. There are two other versions. If we take cosine squared, well, cosine squared a plus sine squared a is equal to 1. If we solve for cosine squared, we get 1 minus sine squared. So I can make this substitution in for cosine squared, and what we're going to get is 1 minus sine squared a minus sine squared a. So what we end up with is 1 minus 2 sine squared a. So this is a second version of the double angle for cosine. And then if we go back to the first version, if we now make a substitution for sine squared, well, over here, instead of solving for cosine squared, let's solve for sine squared. We're going to say sine squared a equals 1 minus cosine squared a. And then if we substitute this, 1 minus cosine squared, for sine squared here, we are going to end up with cosine squared a minus 1 minus cosine squared a, which is cosine squared a minus 1 plus cosine squared a, and that gets us to 2 cosine squared a minus 1. So this is yet a third version of the double angle for cosine. And so for each of these, we typically will write this like cosine of 2a. So cosine 2a. So cosine, double angle for cosine is unique because there are 3 versions that appear quite frequently. Now, yes, you will need to memorize these so that we can use them. However, if we can just remember where each of these are coming from, you really just need to know the sum formula for cosine. And if we can do that, then we can get each of these in this manner. And then the double angle for tangent, well, this is the same thing as tangent of a plus a. So the sum formula for tangent is tangent of the first plus tangent of the second divided by 1 minus tangent of the first, tangent of the second. Cleaning this up a little bit, we're going to have 2 tangent of a in the numerator divided by 1 minus tangent squared of a. So that is the double angle for tangent. So one way that we will use the double angle formulas is in the process of verifying a trig identity. So here we have sine of 2x is equal to negative 2 sine x times sine of x minus pi over 2. Now right here, there's a couple ways we can think about this. One way would be to expand this using the difference formula for sine. So we're going to say negative 2 sine x. Now to expand this, this is just the difference of sine. So we're going to say sine of the first times cosine of the second. Keep the operator the same. Sine of the second times cosine of the first. So simplifying what's inside the brackets, we're going to have, well, cosine of pi over 2 is equal to 0 on the unit circle. So we're going to have sine x times 0 is 0 minus sine of pi over 2 is 1. So 1 times cosine of x is negative cosine of x. We end up with negative sine x times negative cosine of x. So on the right hand side, negative times negative is positive, 2 sine x cosine x. And that looks very much like the double angle formula for sine. So if we just bring this down and rewrite that as the double angle formula for sine, we have the left side equal to the right side. We've already talked about the double angle formulas. Now let's address the half angle formulas. And to derive the half angle formulas, we start with cosine. So cosine of 2x, that's one of the double angle formulas for cosine. So let's solve for cosine squared first. So I'm going to add 1 to both sides. Cosine of 2x plus 1 is equal to 2 cosine squared x. And divide both sides by 2. We get cosine 2x plus 1 divided by 2 is equal to cosine squared x. Now on the right hand side, we want just cosine here. So let's take the square root of both sides. So on the right hand side, we're going to have cosine of x is equal to plus or minus square root of cosine 2x plus 1 divided by 2 here. Now what we can do is, if we make a substitution, let's let x equal y over 2. And what this allows us to do is, I can substitute here and here for y over 2. So back up here, we're going to have plus or minus the square root of cosine of 2 times, in place of x, we're going to write y over 2 plus 1 divided by 2. That's going to equal cosine of y over 2. So in the numerator of the radicand, we're going to have those 2's are going to cancel. So we end up with cosine of y plus 1 divided by 2. That is equal to cosine of y over 2. And usually how this is written, I'll go to a new page here. Usually how this is written will be cosine of y over 2 is equal to plus or minus square root. I'm just going to flip the numerator, 1 plus cosine of x all over 2. Now, when we're talking about whether to take the plus or minus here, well, cosine is positive in the first and fourth quadrants. Cosine is negative in the second and third quadrants. So we'll use plus when x is in 1 or 4. We will use negative when x is in second quadrant or third quadrant. So the quadrant that the angle is in determines whether we use the plus or minus here. And I seem to have written both variables. Let's just clean this up. I'm going to change this y to an x here. Okay, so if our original value x is in the first quadrant or the fourth quadrant, we're going to use plus. If it's in the second quadrant or the third quadrant, we're going to use negative. Now, the other half-angle identities can be derived in much the same way. I'm not going to do that here. You can check that out in the book if you would like. But let's see what those half-angle identities look like. So half-angle for sine is going to equal positive or negative square root. The only difference is going to be this is 1 minus cosine x over 2. And a similar idea with the plus or minus. For sine, we're going to use positive. I'm having trouble writing my plus signs. We're going to use positive when x is in quadrant 1 or quadrant 2. This is where sine has a positive value in quadrant 1 or 2. And we will use negative when x is in quadrant 3 and 4. That's where sine takes on a negative value. And then the half angle for tangent, this is going to be plus or minus the square root of 1 minus cosine x over 1 plus cosine x. And this is helpful to remember, or this is easy to remember, because tangent is just sine over cosine. So the sine is, the 1 minus cosine x is coming from the half angle of sine, and then in the denominator, 1 plus cosine x is coming from the half angle for cosine. So tangent is sine over cosine, so if you can remember the half angle for cosine and the half angle for sine, well, the half angle for tangent comes from taking sine over cosine. And then for which sign to use, whether positive or negative, we're going to use positive when tangent is positive, so we'll use positive when x is in quadrant 1 or quadrant 3, and then we'll use a negative when x is in quadrant 2 or quadrant 4, because that's where tangent takes on a negative value. Let's look at an example. This is not in the notes, but I think it's valuable and I should have it in the notes. So let's go through this. We want to verify this identity. 2 sine squared of theta over 2 is equal to 1 minus cosine theta. Now what we need to realize is that this sine squared of theta over 2, this is really just the same thing as sine of theta over 2 squared. So sine of theta over 2, well, we can use the half angle identity here. So we're going to have 2 the square root plus or minus the square root of 1 minus cosine theta over 2. And we're going to square that. So when we square a radical, we just get the radicand. And since we're squaring, it doesn't matter whether we were starting out with a positive or negative. A positive squared is positive, and negative squared is positive. So either way, we end up with a positive value here. So what we get is 2 times 1 minus cosine theta all over 2. And we can cancel out those 2. So we get 1 minus cosine theta is equal to 1 minus cosine theta, and that verifies the identity. So when we see something like this, sine squared of a half angle, well, that really is just going to be the radicand of the half angle identity. This is a common way we're going to use these half angle identities. And then one more example, find the exact value of cosine 157.5. Now to solve this, we need to realize that 157.5 degrees, well, that's not on the unit circle, but if we multiply that by 2, we get 315 degrees, and 315 degrees is on the unit circle. So what we're going to do is we're going to let that equal our angle theta, and we can apply the half angle identity here because 157.5 is half of this angle 315. So how we're going to do this is we will say that cosine of 315 over 2, and we want to write it this way because 315 divided by 2 gets us the actual angle we're trying to find. So cosine 315 over 2. Now we're going to use the negative sign here because 157.5, that's in quadrant number 2, and cosine is negative in quadrant number 2. So negative square root of 1 plus cosine. Now for theta, we're going to use 315 divided by 2. So from here, we just need to simplify. And this is kind of a complex simplification, or rather, it doesn't get simplified very much. It still seems kind of complicated. But 1 plus cosine of 315 is positive root 2 over 2, all divided by 2. Now to simplify this, what I'm going to do is I'm going to multiply the top by 2 and the bottom by 2. And this is going to remove the denominator in the complex fraction. So negative square root 2 plus square root 2 all over 4 here. Now we have a radical inside of a radical. This is not something we really want, but we can leave it this way. Kind of the only other thing we're going to be able to do is take the square root of the denominator. So 2 plus square root 2 like this all over 2. And that would be equal to cosine of 315 over 2, which is cosine of 157.5 degrees. And so this is kind of a funky solution. Not something probably that we're very familiar with, seeing a value in this form, a radical inside of a radical, but this is allowed. And we can always check, we could check our work on this by typing this in the calculator. We could evaluate cosine 157.5 degrees, and if we do that, we're going to get this, whatever this approximates to as a decimal.